There we are. Hi, everybody. Welcome to Which 3D Printer is Right for Me, hosted by Whitmix Corporation. My name is Chelsea Phillips. I'm our digital marketing specialist here at Whitmix, and I'm pleased to introduce you to Sherri Weatherby, who will be talking about all of our different printer options that exist in the dental industry. With that, Sherri, go ahead and get it started.
All right, thank you so much. Hope everyone is having a fantastic Friday. So I am going to be talking about a topic that I'm actually quite passionate about, which is 3D printers. 3D printing technology has absolutely evolved immensely, really over the last 5 years. And, there's all different types of 3D printing technologies out there, different variations. So with that being said, the most popular technologies within our industry would be SLA, DLP, and LCD printing. So typically I kind of jack this word up, but I'm going to do my best to say it right the first time. So we're going to talk about stereolithography printing. So there are, again, different variations. So it's the process of solidifying a photopolymer resin layer by layer that is activated by a UV light engine. So laser SLA, as an example, that technology would be similar to like the Formlabs printer. DLP SLA, you're looking at various printers on the market like the Asiga Max, the Pro 4K, the Envisiontech printers, the Sprint Ray printers, and then you have LCD, which is using like a masking light by LCD. The Accurata printers would be one of those, the Varibuild printer that Whitmix has. And then, of course, you have the other option there with the laser SLA, DLP, and MSLA. So just going to kind of dive in and talk about the most popular printers on the market for our industry. Clearly, there's going to be some out there that I'm not going to hit on today, but this is just really going to give you kind of a foundation and an idea of different printers, price points. We're going to talk about accuracy, as well as build plate size, wavelength, whether it's a 405 or a 385 wavelength, and then also if that printer is open or closed. So with the Formlabs printer, they've really stepped up the quality and accuracy with their next generation printers from their predecessors being the Form 1 and the Form 2. So with the Form 3 and the 3BL, they're using what they call a low force stereolithography printing. Basically, that's using a flexible tank and linear illumination, which increases the reliability and accuracy of their printer. So with that being said, their low-end cost printer is going to be the Form 3 at 3,500. The XY is at 85 micron. However, they claim that you can actually achieve a 25 micron accuracy if you offset the print border. So this process of offsetting the print border is unpredictable, and it's also challenging. You really have to dial that in because there's so many moving parts to a laser SLA printer. With that being said, looking at print time with this particular printer, it's pretty extensive. So I did speak to one of my buddies down in Florida, Brian Johnson, who has the Form 3B, and he said it takes him typically anywhere from 7 to 9 hours to 3D print a full plate of models on his Form 3B at a 50 micron accuracy for crown and bridge models. So this printer is also closed, so you're locked into their resins. You can run it in what they call open mode, but running it in open mode, it's again, very challenging. The next one they have, so they actually have a larger one, which I wasn't aware of until I looked this up, but the Form 3BL, this one has a pretty big build plate, and again, the accuracy on this is 85 micron, but using the technology that they talk about getting the 25 micron accuracy is, you can actually do that with this printer as well. So again, this is a 405 wavelength. It is also closed. You can run it in open mode. So again, the print time is also an issue with this printer. So moving on, we have the Envisiontech Envision One. So this is actually a great printer. The native XY accuracy on this is 93 micron, but you can achieve a 60 micron accuracy with this printer. It has a decent build plate size of 7 inches by almost 4 inches on the XY, with almost a total height on that Z axis of almost 7 inches. So this printer is fast because it uses CDLM technology, which is basically a DLP printer that has continuous printing. With a lot of printers on the market that's a standard DLP, what happens is you've got your projector underneath, you've got your build plate coming down, and the projector is projecting the image in slices. That UV light flashes, cures that layer, and then it raises up, separates from the resin vat, lowers back down for the next layer. With CDLM technology, that's not the case. It actually continues to grow. So where you get that additional speed with your print job is the fact that it's just growing, and it doesn't have to keep going up and down in between layers. So the price point on this printer is at $17,900 retail. The system is also closed. With that being said, they do have a ton of options for resins between the Envisiontech and Nextent product line. I believe, and I may be misspeaking, I hope not, but I believe this printer is also validated for the Keystone splint resin. Envisiontech also brought out a desktop printer called the D4K Pro, and this adjusted retail on this printer is $14,990. It is a DLP printer, so it doesn't have that continuous growth that the Envision One has. But the XY accuracy on this is 50 micron. That build plate size is pretty decent, just under 6 inches and 3.3 inches on the XY. And then on that Z axis for your height, you're looking at 4.3 inches. So this is also a 385 wavelength. And again, it is a closed system, tying back to the Envisiontech Nextent resins. And again, I also believe the Keysoft. The Cura Prince from Calzer. So this is also a closed printer that has a 405 wavelength. It is quite accurate at 54 micron on the XY. So with DLP technology, again, you've got that projector, and you can see that image there on the screen that kind of shows how the projector projects that image like this. So the closer the projector is to the glass plate, the more accurate the print is. But doing that, you lose build plate space. So the build plate on this printer is actually quite small, if you ask me. So when pulling that projector back, you will lose some of the accuracy on the XY, but you do gain that build plate space. But we'll talk a little bit more about that with some new technology. Well, not new technology, but some technology with DLP printers. Let's see. Then we have the Nextent 5110. This is also a DLP printer. Last I checked, it retailed at $10,000. You do get their UV print box at $1,800. With their resins, you do have to mix them up extensively prior to use. So they came out with this really cool 3D print resin mixer. It's kind of like a hot dog roller, if you will, but you want to keep those bottles on that roller, constantly moving the material prior to use. And then they also provide additional training for $1,450. So the XY on this is 65 microns, so it is most certainly accurate for crown and bridge. The build plate on it's pretty decent at 4.9 inches by 2.8 inches on the XY, with your Z-axis height being at 7.7 inches. This is a 405 wavelength, and again, it is also a closed system. Moving on, we have the new Sprint Ray Pro 95. Now this printer has a great price point at $6,750. The only other fees I know of that's tied to this printer, they do have for an additional software, it's $209 annually. And what that $209 gets you, it allows you to open up to specific resins that they have approved for use with their printer. So it is a closed printer, but semi-open. If you get this $209 a year service with them, and then you can tie in a few other resins that they've actually approved for use with their printer. So With that being said, the accuracy on this printer is 95 micron and has a fairly decent build plate size as well. And it is a 405 wavelength. Then we have the SprintRay Pro 55, also at 6750 with the same concept with being semi-open for resins that they have approved, paying that additional $209 annually. The XY is 55 micron, so it's very accurate. And then we have the build plate space on there at 105 by 59 millimeters. So moving on to this big boy, the Carbon M2. This is also CDLM, continuous DLP printing, very similar to what the Envision One printer has. So again, it's going to continue to grow as you do your print. So this printer you don't own, you lease. So you can lease this printer for $50,000 for a 3-year lease. You do pay a $10,000 install and training fee, as well as $5,000 for shipping. So this printer is closed, and it has a great build plate size, 7.4 inches by 4.6 on the XY, with that Z-axis height totaling 12.8 inches. The accuracy is also solid at 75 micron. Let's see. Then we move on to the Asiga Max. Not just because I sell this printer, but it is definitely one of my favorite printers, just because it's open, it's accurate, it's dependable, it's reliable. So this printer retails just under $11,000 at $10,990. Has a decent build plate space of 4.69 by 2.64 inches for the XY. And then your Z-axis height, you've got 2.95 inches. With that Z-axis height, you can actually, in the Composer software that comes with this printer, you can create kind of scaffolding, if you will. So throughout the day, you want to print one row at a time, and to be a lean manufacturer. So, but at the end of the day, let's say you have 9 models left and you want to knock those out, but it's, you know, you're ready to go home and live life. Well, in that software, you can actually create that stack where you have multiple rows, up to 3 rows, basically, with models, and you can nest your models on those 3 rows, hit start, leave, go home, live life, come back in the morning, and the printer's done its job. You're ready to post process. So, with that being said, this printer is a 385 wavelength, and it is a true open materials printer. If you go to the Asiga website, you're actually able to see that there's over 400 material files out there for this printer. The Asiga Pro 4K 80, this is also DLP technology. It does have a 4K projector. This printer retails just under $25,000 at $24,990. The native XY accuracy on this printer is 80 micron. However, you're going to be running this in what is called 4K mode, and the printer actually comes set to start off in 4K mode. And when you run that in 4K mode, it's actually printing at a 56 micron accuracy on the XY. So when you get a build plate as big as this, measuring at 8.54 inches by 4.8 on the XY, being able to print that at a 56 micron accuracy, it's pretty incredible. So, and this is, again, a true open materials printer. It also has a 385 wavelength. So, and I'll get a little bit further into 405 versus 385, but I do want to point out that when you're using a printer that's a 405 wavelength, you're limited to using resins that are formulated for a 405. When you're using a 385 printer, such as the Asiga and the Envisiontech, you can actually print 385 and 405 resins on those printers. So your options definitely open up when you're using a 385 wavelength printer versus a 405. So let's talk a little bit about curing lights for FDA approved resins. You know, we've come out with a lot, you know, and I kind of got these slides jumbled up. Let me go to this here, considering I just started jumping into class 2 resins. So we have now denture resins, we have temp resins, we have a permanent crown resin, we have splint resin. So anything class 2, meaning it goes in the mouth for more than 30 days, I believe it is. So anything that's in the mouth for that length of time is class 2. And when you're using an FDA approved resin, you actually have to use the approved printer, the approved design software, the approved curing light that is tied to that resin. So whenever you look at a resin, whether it be, Whitmix hard splint or the Keysoft soft splint, Keystone has a hard as well now, all these denture resins that are hitting the market, you want to look at that 510K build out and make sure that you're picking the correct curing light that is tied to that. So I kind of hijacked this from our website. It just kind of gives you an idea as to what you're looking at. So some of the more popular lights on the market would be the Auto Flash, the IntelliRay. They have the IntelliRay 600 as well as the 400, and then the CureBox Plus. So looking at this chart, you can see, they have different light intensities, different wavelengths, the lamp power is different, and that's going to affect how you cure your FDA approved resin. So you're going to want to make sure that whatever resin you're looking for, that you're actually looking at the build out of their 510K, look at their IFU, and get the right curing light in your hands. These curing lights that I have listed here range anywhere from $955 to $3,500. Actually, the IntelliRay 600, and that one actually is 4,000. I think it says 5,500 on there, but it's actually 4,000. So really, depending on what you're printing is really going to be dependent on which curing light that you end up getting moving forward. So I'm going to jump back to where I was because I want to talk about 385 versus 405 as well as the slide here. So Corey, he's kind of one of our 3D printing gurus, if you will. He put this together and figured out a way how to calculate the proper exposure times for open materials printers. So this is actually the formula that you would use to calculate a material file for any resin that you choose to use. So, we have customers that's gone with us with Asiga and they find random resins on the market that they want to try. If there's not a material file, they can either send that to us and we will calculate the material file for them, or Corey will hop on, or Evan, and teach you how to do this using this formula. So there is a pretty cool way to kind of think outside of the box with different resins with those open material printers. So 385 versus 405. So as you can see here, some of the differences, really when it comes to clear resins, if anyone is going to use a clear resin, I would encourage you, if you want it to be truly clear, not meaning cloudy, but clear, not yellowing, 385 really is definitely the way to go. A 405 tends to really make the resins a little bit more on the yellow side. Curing lights also play a role in that, because if that curing light runs really hot, that curing light will also tend to yellow those clear resins. But again, the biggest thing is, for me personally, it's kind of a no-brainer to go with 385, just because you have such a wide range of options to go with as far as resins. Now, if you say, you know what, Sherri, I just want to print models, I'm not printing anything else, then definitely a 405 would definitely, be on that list of consideration as well. So here's what I recommend doing. I know it's a lot of information to take in. And again, there's so many other printers on the market that I didn't even hit on. So that list is pretty expansive. And it's tough when you are looking at all these options, trying to figure out which printer is really going to suit your needs the best. So what I would look at is, do you want a 385 printer or 405? Do you want a printer that is open or closed? Do you want to lease or do you want to own? There's just so many different options and different factors that are really going to play a role in which printers you need to narrow your list down to. So once you narrow that list, I would reach out to every single one of those printer manufacturers and ask them for a test print. So with models as an example, you would want to send a raw scan to that printer manufacturer or the reseller of the printer and let them model build that file, let them 3D print it, and you need to ask questions, just as I have bulleted here. What is the pixel accuracy of this printer? What micron layer thickness was my test print printed at? How long did it take to print? When you ask how long it took to print, you can also ask, what was the cost to print that model? Is this an open materials printer? How much is your resin? Ask questions about consumables and trays and support fees and service agreements. So there's really a lot of questions you need to ask. So let's say you have three printers on your list. You reach out to all three of those manufacturers or resellers, send the same exact file to each one of them and ask the same exact questions. That way you have an apples to apples comparison from all three platforms and get those test prints back, do your comparisons for quality and accuracy. There is a really cool set of software that you can use. What did I do here? Here we go. So there's a really cool software out there called 3D Reshaper. And we actually have that at Whitmix. So if you don't have access to this and you want to get a test print from us for the Asiga printer, you can send all of your other models and we can actually run this through the system and show you where the inaccuracies are with each one of those models. And you can even just mark them A, B, C. That way you know which one is which. We can give you the results and just let those results speak for themselves. So this is a really cool way to actually check the accuracy of the models that you're printing. So we've already talked about that. With that being said, that is all I have. If anyone has questions, I am happy to answer anything you have.
Hi, Sherri. Welcome back. We do have a few questions that came in. The first one says, what about big industrial Prodways moving light? They print 60 models per hour and only cost $100, I think.
Or maybe that's $100 or 100,000. I don't know. The punctuation is off there. So I am not familiar with that particular printer. So I have nothing that I can really add to educational wise on that printer.
Perfect. The next question is, how do LCD printers compare to DLP?
So LCD printers, actually, it's a great, LCD printers are great. We actually have one called the Very Build, and it costs less to maintain them. It costs less to repair them. And those type of printers can actually be repaired in-house, meaning whether it's at a lab or a doctor's office with video instructions. So typically speaking though, LCD printers are slower than a DLP printer. So example, what would take you 40 minutes to print a model with a typical base thickness on the Asiga Max at a 50 micron layer thickness, it would take you 40 minutes to print that on the Max, which is DLP. To print it on the Very Build, that same model at a 50 micron layer thickness, you're looking at about a 2-hour and 45-minute print time. So LCD printers are slower. However, they're very accurate. Very easy to maintain and inexpensive to maintain.
Wonderful. Those are the only questions that have come in so far. Has anybody got any last minute questions? Feel free to type them into the Q&A or the chat box. We're here to answer them.
All right. Well, I was going to throw this in because I was hoping that Corey or Evan, one of our techs, could actually join us for this presentation. Through COVID, we actually did a ton of fantastic webinars that were educational, and on Fridays they had Hawaiian Shirt Friday. So with that being said, I don't have a Hawaiian shirt, but I put on something a little floral to be a little festive. Thank you, Chelsea, for joining me in that. And we definitely missed having one of our boys on here with us. So, yes. All right, I do see another question, the Rapid Shape DLP. I am not certain if that one is open. Honestly, I just came across a lab down in Texas that has one. He's actually going to be getting back to me, giving me feedback. I know they weren't real strong in the States here, going through Strawman. So I don't know if they're going to be, opening that up and selling more in the States. But unfortunately, I don't have an answer for you. If you want to shoot me an email or even a text, which should be on that screen right here, with your contact information, and I will certainly reach out to the lab that I know down in Texas and get that information for you.
I'm also going to throw a shameless plug in there. If you're interested in getting into the digital technology and the digital world, we are hosting a digital forum in October, the 29th and the 30th, and we will be talking all things digital. We'll have main stage breakout sessions. We've got some amazing speakers who are going to be talking, and it is worth CE credit there as well. And we're very excited about it.
Well, thank you everyone for coming. If you have other questions that you think of later, feel free to shoot me a text or an email. I'm happy to answer at any time.
Thanks, everyone.
All right. Thank you. Take care.